He wanted to keep me for PhD, but then I actually rejected that offer. When you directly just send out the email, code email to the professor, usually they won't reply. The field is actually moving a lot, very, very fast.
Songyou Peng is a postdoctoral researcher in the prestigious ETH University. He's also starting a position as a research scientist in Google, a feat accomplished by very few PhD students or postdoctoral researchers. In a world where just getting a paper accepted in a prestigious conference like NeurIPS or ICML is getting increasingly challenging, Songyou Peng has an oral paper titled Shape as Points. At that time, the acceptance rate for an oral paper in NeurIPS was just 0.6%. In today's show, he's going to share with us how he started with this exciting journey in AI and 3D. He's also going to share with us the impact that the large foundation models are having on 3D. On top of that, he's also going to share with us his PhD journey. He's also got some tips and advice for PhD students who are getting started in the field. Without further ado, let's get started. Songyou Peng, thank you so much for coming down for the ViBOT show. Could you just tell us like how you got started with computing and how you got into the field?
Yeah. Well, good. So first, I thanks for the invite, right, to the show, and yeah, and good to know that I'm one of the first to do this, and then like to set the whole thing. Yeah, but yeah, so I think from the very, very beginning, that's actually dated back to my bachelor. So when I in maybe third year of my bachelor, and we had a course called digital image processing. And then obviously I took that course, and at the same time, there's another course called pattern recognition. So like that, those two are all a selective course, right? So I selected them by myself, and then I just took it, and then oh, it's very different from what I learned before. So my major was automation, more like I don't know, like this electronic engineering or like mechanical engineering kind of automation. So it's very different from what I learned. I really like how I can, like, for example, program something and then see, oh, like the stuff can directly appear there and then change. So it's very cool to me. So and then at that time I was thinking about like doing a master, and then I would, and so with this positive experience in like digital image processing and also some machine learning things, so I was starting applying for stuff in computer vision or like artificial intelligence in general. Yeah, that was basically starting from there. And it's very, very long time ago. It was probably 2014 or even 2013. So more than
Yeah,
10 years ago. Yeah.
it's a long time now. So
Yeah.
how did that occur that you wanted to do masters in like ViBOT, which is a vision and robotics masters,
Mhm.
particularly in
It's
France?
yeah, exactly. So yeah, so I was applying to many places, like including some places in UK, and then some and then I was actually mainly applying for the university in the UK because I started applying very late, right? So like all this you need to prepare a lot more if you want to go to the US. So I just wanted to do a master at that time. And then so so if I go to UK or Australia and these places, you just need the IELTS, right? So I was preparing for IELTS for a few months, and then yeah, and get some scores and then apply. But at the beginning, I really just wanted to apply for the UK. However, like towards the end of the application, some of my friends, one of my friends just recommended me this. Hey, look at this. This is relevant to you. And that's ViBOT. Basically,
Wow.
it's like the Erasmus Mundus masters in general. So I was checking, and I found ViBOT. I also found another one like in robotics, and it's like between some Polish university and I think Czech Republic universities. Yeah. And but then so in the end I applied to both, and then I got into ViBOT, and I also had some offers from some UK university. So after some thoughts, I said, oh, I I think it makes sense to go to ViBOT because personally I don't care too much about the ranking of the university. And then also like the ViBOT is way cheaper than the UK university.
Yeah,
And then
definitely.
also yeah, also you can get some I think allowances. So I said, okay, I will go for that. Yeah.
Yeah, definitely. Yeah, I mean, it's definitely the ranking of the universities is overrated, isn't it? If you're really good, it doesn't matter what masters you do, like you can definitely get that to the top. Yeah, you're a very good example of that, obviously.
Yeah, I think that so first I'm very lucky, but also not just me, right? Many of our I don't know seniors and also my peers, they appear to be somewhat very great afterwards, right? So even my group at ETH Zurich, like there are two previous Bible students actually will be before me.
Ah,
Yeah.
I
So
see.
and also for example, some other people are in other groups in at ETH. Yeah.
Ah, I see. I see. Yeah, so did you directly apply for PhD or like did you take a break or like how did you end up in ETH from your masters?
Yeah, so I mean, first I think it's very I'm very lucky to get into ETH, but like as I said, right, so it's not I I it's not that like I directly apply for my PhD. So first I did a internship in France in
Okay.
England, right?
Yeah.
And then basically because of that experience, my supervisor there recommended me to Munich to do master thesis. So I also had a great time there with Daniel Kremers. And then
Wow. Okay.
yes, and then but then like so he wanted to keep me for PhD, but then actually rejected that offer because
Okay.
because I so at that time during my master thesis I was working on something like purely optimization based like a 3D reconstruction,
Hmm.
but then I had no deep learning experience at all. And then I know if I stay with this group I will basically have to continue doing what I have been doing, and I don't know. But so I'm not sure whether I want to do that because not, I already know at that time, like 2017, like the deep learning was already going into like 3D vision. Not that many, not as
Yeah.
much as now, but like at that time, it's already like a lot going on. But I had zero experience in deep learning or even training a neural network myself. And then like
Yeah.
so I don't want to go for the PhD right now. I want to really do a PhD. I know I want to do a PhD, but I want to figure out what I really want to do first for my PhD. So that's why I was like applying for some jobs actually in between, which allow me to learn or have hands-on experience in deep learning. Yeah.
Yeah. You're one of the few who has like worked in deep learning for a decade now. So how do you see basically deep learning research has evolved in the past, 8 to 10 years?
Well, again, like so, I actually did not work for too long on deep learning. I started working on deep learning, or I don't know, especially like deep learning for computer vision, right? Starting from
Yeah.
like beginning of 2018. And then as people know, the like starting from like 2012, this AlexNet came out already, like basically start the whole trend of everything. But I would say that so at least like since I started during like the deep learning until now, oh, so many things change, and then especially in the field of like 3D vision, 3D
Hmm.
computer vision, because like before like this kind of 2D computer vision tasks like depth estimation or image classification or like recognition, all these kind of things are only focused on 2D tasks, right? Like also like
Yeah.
hacking, etc., semantic segmentation. But on 3D, yeah, it's actually really I don't know, take off. I think in starting from maybe 2017 or something like that, and then more
Yeah.
and more people really want to see how can they replace different components in 3D pipeline with deep learning. Yeah, but it's like now everything is about deep learning, and which is good and bad at the same time because now, like with deep learning, everything becomes so easy as long as you have data, right? Or like resources.
Yeah.
But on the other hand, I realized that less and less people understand those pure like optimization or geometry kind of things that like they
Yeah.
actually, it was prerequisite for many people or for the PhD before, right? If you do 3D vision.
Yeah,
Yeah.
exactly. Like we were spending so much time learning all this geometry stuff, and the course was so mathematical when we were doing it. And then now, if you
Yeah,
look at, it's all just about coding. It's more of software engineering. It's just about
exactly.
throwing in data into like all these algorithms.
Yeah, exactly.
Yeah, we
So
quite
it's
enjoyed those days, isn't it? Where we did a lot of mathematics on paper and stuff.
well, I would say it's a different era, and I mean you definitely learn different things for sure. But I also enjoy the era now because it's actually lower the ancient requisite prerequisite for different people, right? So like more and more people can work on problems in this field, and then the field is moving really fast because of that
Yeah,
as well.
yeah.
Yeah.
So,
So
fast forward to 2024 now, generative AI is a big stuff. Like, so how do you see generative AI in 3D? Like, what's the sort of impact you're having?
yeah, I mean, if you ask me this question, 1 month ago, I had a different answer, right? So because at that time it was well, there are a lot of works in the field of this text to 3D or image to 3D, right? Like basically giving some text, you can generate the 3D model or like 3D objects, and then the quality is getting better and better. The speed is getting much faster than, I don't know, just a year ago. So the field is actually moving a lot very, very fast. But why I said like, well, you ask me now, I had different answer because the Sora came out, right, from OpenAI.
Yeah, yeah,
And this actually really changed. I think not just me, I talked to different people about Sora, like in our field, and also like some related 3D vision field, is that what people are a little bit lost or feels pretty frustrated, and because they know, wait, if we already have this amazing text to video kind of work, right, and then like you can generate very consistent video, why do we even need our current text to 3D kind of thing? because because I mean, like, what's the point of having the 3D model? Like one key component is that you want to render nice video out, or you want to have I don't know, some downstream tasks, including this kind of video, right? And then also giving a constant 3D constant video, you are also able to simply get the 3D reconstruction out from this kind of video if it's consistent enough. So this, so I will not say, well, the 3D computer vision is dead or all of this, right? No, definitely not. I think like definitely we actually even need to have some of this like geometry information to inject those information into Sora to help them to really better understand the physical world as well. But what I try to say is that people, at least including me, like are thinking about like what we should do in the field also. So the field is moving really fast, and then how we can adapt ourselves into this big change. Yeah, that's a question we need to ask. Yeah.
yeah. Definitely, definitely moving fast. No doubt about that. I'm finding it challenging to just keep up with the amount of papers that are just churning out really from each of the labs. So
Yeah.
that leads me to the question of like, so what are you working on these days in your lab? What is the focus, main focus?
So I have been well, first, like, so my PhD was about like 3D reconstruction, and
Hmm.
then also about 3D scene understanding,
Yeah,
right? So it's more about like this kind of from middle level to high level kind of 3D vision tasks, right? And so, but because like again, like the field is moving very fast because of this like large language model, or in general large vision language model,
yeah.
or just what we call this foundation model, right? So recently I have been focusing a lot on how can we actually adapt those foundation models for the 3D vision tasks, for example. how can we use it for 3D reconstruction? How do we benefit the 3D scene understanding, and also maybe neural rendering? And also that's like basically a key thing I have been working on.
Mhm.
And also on the side, I was also wondering how can we ourselves can develop our own foundation models for some specific tasks
Yeah.
as well. So yeah, that's like the thing.
Yeah. So, what does it take to develop a foundation model for 3D? I know it's there's one more dimension to the data, and like it's much more involved. Or what's your opinion? Are there any labs working on it? Or
You mean like 3D foundation model?
yeah, yeah,
Yeah, there are like a lot of things going on, right? Like in the 3D foundation model world, for example, like all this text to 3D kind of thing, like Gen AI kind of work, right? So given some text, you can directly generate not just the image like Stable Diffusion or Sora, like you get the video, but you can directly get the 3D model out or like 3D reconstruction out, given the text or given one single image. So this kind of line of work active research going on, but like I think the key limitation right now is the data.
yeah,
So for example, like in Stable Diffusion, they use like 5 billion, this Lion 5 billion data set to train, right?
yeah,
And like, but then like how many so right now the biggest 3D object level data set, they only have I think like 1 million or so kind of number of data, which is like I don't know, like more than like 1,000 times less than like the image data set, right? So I don't know how many they use for Sora, but definitely also I think a lot. So I think this limits the quality of the current foundation model
yeah,
in 3D especially. Yeah.
yeah. So is it more of like self-supervised these days, or how much of supervision do you need? As how much are we moving away from supervised learning to sort of like unlabeled data in terms of 3D?
I think so in terms of 3D, I think so right now they are using some kind of so of course if you have the ground truth 3D, of course you want to use it, but also people use kind of multi-view images for training, which is a weaker kind of supervision, right? So just imagine like NERF or
Yeah.
like near radiance field, right? So you can get a 3D model out from just 2D images or 2D post images, right? So many people are like doing stuff like this. In my opinion, this is kind of like a weak supervision signal,
Yeah.
right? Because you
Hmm.
don't really have the 3D, but you just have the 2D images and you can still get the 3D consistent models out. So, but similar ideas will apply to also to train the 3D foundation models as well. Yeah.
Okay. Yeah, you mentioned nerves, so but then in the past 6 months or so, I'm seeing a lot going on about Gaussian splatting. So is that an area you guys are exploring, or like what is it even like? A lot of people are wondering what Gaussian splatting is.
Mhm. Yeah, so I think Gaussian splatting is very also very exciting. It's well, it's non-nerf, but it was inspired by nerf, right? So nerf is uh kind of an implicit representation in the way that like all the information, as I said, right? So you get a 3D consistent model, but it's only kept inside some neural networks. Like for example, either an MLP or either like or some like feature grades or some I don't know hash grade. That's like the instant GP, right? So, but those are implicit representation, meaning that like so giving a random point in the space, they can render, they can give you out, you pass this coordinates into the network, you can get the density and the color out. So that's the implicit one, right? And then you do the volume rendering for that. But like in Gaussian splatting, what people do instead is not the volume rendering, right? So what they do is that so they initialize the shape and color from some the structure from motion point cloud from CoMap, right?
Hmm.
It's already some point clouds on the surface, and then you can build on the points some Gaussian representations basically on the surface. And then inside each Gaussian, you have different properties, including I don't know, color, including like opacity or density, and also some like the scale of the Gaussian, the rotation and the translation of the Gaussian, etc., etc. So basically, these are the scene representation instead of a neural network, right? So these things become explicit because there's no network at all in there. And then they develop like sophisticated rendering, or it's basically like splatting, right? So how do you call the splatting? It's basically you can throw the Gaussian to your image. So it's like a splat on the image.
Okay.
So it's a sort of like a rasterization kind of things. And then yeah, but this give you also really nice rendering results because yeah they just show it to be also basically similar quality as nerve, but can be trained much faster than nerve.
Oh, I see. Yeah, that's where the advantage comes in.
Yeah,
So do you
exactly.
see it as in the next 2 years or so? Is it going to be more of Gaussian splatting the way the field is moving?
I think maybe so. Gaussian splatting is definitely well, many people are actively working on that, right? It's basically, but this reminds me of instant NGP like from NVIDIA in 2022, which is
Okay.
just like a year and a half ago, right? It's a advanced version of NeRF, right? They have a advanced version of the representation, and then also show that like the training can be really fast, the rendering is also real time, and then people are like really looking into that. But then people realized, oh, it's good, but it's still not explicit enough, so you cannot really understand everything very well. So the Gaussian splatting came out, and I feel that like maybe who knows in the future, like maybe right now definitely still people are working on stuff related to Gaussian splatting. There are still open questions there, but maybe in a year or two there will be another representation and for nerve like this
Yeah.
kind of rendering thing. So you never know, like the field is really moving too fast. Yeah.
Yeah, that's one wonderful insight. So let's slightly change gears and try to understand. Like, so you've done a PhD in a prestigious university. So walk us through how a typical day looks like while you're doing a PhD.
Yeah, so well, uh, I guess it's really depends on different people, right? Also really depends on I also don't think it's related to the university, but I think it's more related to your supervisors.
Okay.
So so I mean the style of your supervisors, like some supervisors are really hands-on, so they want to meet you more often, like once or twice or even every day. Uh, right. So I know these kind of things happens, right?
Yeah.
Especially for the younger professor or like assistant professor who need to get tenure, right? So they are
Hmm.
more stressful. So like but this is good and bad on the same time, right? So my supervisor, so I have two supervisors, one at ETH Zurich and the other one at Max Planck Institute for Intelligence
Okay.
Systems in Germany, in
Hmm.
Tübingen. And so these two supervisors, I'm really lucky to have both of them because they can provide me different kind of stuff I need for my PhD, right? So
Okay.
yeah, but then like I can tell that so how when I actually spent 1 year in Tübingen with my second supervisor, right? But like 3 years in Zurich. So I can tell you a little bit about like what's the difference in each side, right? So
Sure.
but when I'm mainly in Zurich, right?
Okay.
So here is very how do you say like you have a lot of freedom because like the professor is pretty established and then also he allows you to explore whatever you want to do. So we actually don't have a fixed meeting.
Okay.
Um, I don't know, weekly meeting or bi-weekly meeting. No, we don't. But we even it's funny that at the very beginning we meet maybe like once or twice a year, and then
Okay.
but then like people are complaining about that, so he changed to like every 3 months, I think. So like I call this a seasonal meeting, right? So
Okay. Once every
yeah,
season. Hmm.
once every season. Yes, so basically he want to catch up with you. Hey, how's it going and what you are doing, right? So, but yeah, so but the good thing here is the daily life here is that like well you can really go whenever you want
Yeah.
into the office, or you can just work from home, or like all this like this not an issue. But I think with this kind of very free or relaxed environment, this also actually give you quite some inspirations as well, because like you are not really not pushed, right? You can actually explore something more risky. So it's
Yeah.
not something short sight, right? So
Yeah.
you can actually take 1 full year to work on one project, or even more than 1 year for one project. It's fine, right? But I think, yeah, I think that's the good thing about this place. And also, I mean, all the colleagues here are super amazing.
Yeah.
All of them are very smart. Like, I think
So
like they're all smarter than me. Yeah,
so
so
you're saying that there's a lot of freedom, and so there's also a scale of risk, right, which you can slide between like low risk project and then choose a very
yeah,
high risk project.
yeah.
Okay. Yeah.
I think so. Yeah. So basically, with a more relaxed, or I don't know, with the support of your supervisor, right? So you will be able to basically and do something more risky, right? Or like maybe more impactful afterwards. But so that's a balance. So yeah,
Yeah. So who are the supervisors like, by the way, in Zurich and
in Zurich, yeah, in
Bern?
Zurich is my supervisor is Mark Polyface,
Oh, wow. Okay.
and,
One of the
and
gods
then,
of 3D.
yeah, well, like before deep learning, yes.
Okay. Yeah.
And then in Tübingen is Andreas Geiger, and
Yeah. Yeah. Hmm.
he was famous for like the Kitty dataset
Yeah. Sure.
and also some fancy works afterwards. Yes. So like on the other hand, right? So I said like when I was in Tübingen, or
Hmm.
actually I my research is more aligned with Andreas. So even if I am in Zurich, I'm actually working together with him and also the people in his team in Tübingen. So I meet him more often. Like
Hmm.
it's like I remember like we had meeting once every 2 3 weeks.
Yeah.
But like before the deadline, we meet more often, of course. And then like he's a supervisor who is more hands-on and will actually give you really insightful and useful feedback for
Yeah.
your projects. Yeah.
Sure. So when you're doing your PhD, like how do you get these ideas? Like, do you brainstorm with the postdocs, or do you brainstorm with your supervisor, or is it all by yourself?
I think it's again really depends. So some people I think like they are assigned postdoc, right? So they actually talk with the postdoc more often,
Okay.
right? But for me, I don't have a postdoc.
I
Or
see.
I'm not assigned any postdoc because I had another supervisor in Tübingen, right?
Yeah.
So what I so depends on different projects. So I remember on my first project during my PhD, it was coming out with some discussion with some PhD students in Andreas Geiger's group. So
Hmm.
it's the first project. The second project was even funnier. So it's basically some coming out from a brainstorm, some brainstorm section with one of my friends that I knew from CVPR online in
Yeah.
2020. So we actually got to know each other because we were working on similar topics, and then we were chatting for half an hour online. And then we basically became friends. And then like basically after half a year, when I was trying to search for a project, I was like try to talk to different people. And then he's one of the person I was talking to. And then like really clicked to each other. And then we basically had some ideas together. Yeah. And then yeah, so that's like second project, but on like afterwards, so either I can come up with some ideas just coming out from brainstorming with some colleagues, or yeah, sometimes you just have your own ideas out as well. Yeah.
Yeah. Definitely. Definitely.
Yeah.
And what before you publish a paper, like how long do you spend actually experimenting on that idea, or sort of how long do you take to decide to drop that idea and move on?
Yeah, well, good question. It's again like there's not a universal standard, right? So hey, after 3 months, if you it's no result coming out, you should drop. No, no. So why? So again, like I can just use my own example, right? So
Yeah,
my first project, it was a really quick project because we started in December, something around December, and then we submitted at the beginning of March already. So in total is I think 3 months, including like all the experiments and the writing and everything, right? So that was a very quick, lucky project because I after just 1 week of experiments, I already had some very promising initial results. So that
okay,
that project, I know, okay, we need to pursue it, right? But for example, for the second project, it was not as lucky because I was experimenting for very long time, and then like got stuck in one experiment for like 2 months, and then but then like so we missed the most recent deadline at that time, and I said, okay, now let me just drop it for a while. And then I just like basically leave the project completely, and then I was joining some of my colleagues' project to help them with their submission. But
yeah,
then like after 1 month, so basically after helping them full time for 1 month, and I revisited my own project, right? I said,
yeah,
wait, why I was stuck in on this application for so long, and then why not? So basically change to a different experimental application, right? So and then basically with this kind of mindset change, all of a sudden, hey, and that I have basically the stuff out, and then just after 1 more month or 1 or 2 more months, so we also submit the paper. So at that time I was sort of half abandoned my project, right?
yeah.
Because yeah, I was stuck there for so long. But sometimes when you revisit with a new perspective, then actually you might actually have a thing out as well. Yeah.
So that reminds to the question of, so how do you track these experiments when you're doing it over months actually?
How
So
do you what?
how do you track these experiments? How do you keep a log of these? Do you use any
Ah,
tools or?
Yeah, at that time, so well, nowadays I think many people are using weight and biases, right? So many people
Okay,
are using that. But
okay.
at that time there was not such a tool, so I was basically using TensorBoard, right?
Ah,
So TensorBoard was my best friend for the time,
okay.
right?
Yeah, yeah,
Yeah, yeah,
yeah.
exactly.
Makes sense. Right. Yeah. Let's move on to sort of your time during the your internship and stuff. So I know I've seen that you've done internship with Meta, and then you've done internship with Google. So how is it different from working in academia in PhD? Like, do you want to talk about that?
Yeah, so it's I think to some extent it's similar because I was a research intern in both places, right? Even I was in during the internship. So the goal was actually trying to do some research project that is not like immediately useful for the product. So in this sense, it's similar, but I would say that there are some key differences. First is the resources, right? So
Mm,
definitely get a lot more resources than in the university. Right? I
okay.
remember like, at Google, I was able to just use, I don't know, 200 A100 GPUs at the
Wow.
same time,
Okay.
right? So, but at the university, even it's even hard to get like two
Okay.
from
Yeah.
ETH cluster. So yeah, that's a
Okay.
huge difference. But I would say that that's the good thing. Or but the other side is like you because the internship is a short period of time, right? It's only maybe roughly like 3 4 months
Yeah.
of your time. So and you really wanna do it well, and then you wanna get the research out, get the paper out from there, right? So you are much more stressful than in the university. At least for me, that was the case because as so we had this weekly meeting in the company, right? So they have a bunch of research scientists, not just your manager, but also a few other people will
Yeah.
join your meeting and then give you feedbacks about that. But so that's actually very stressful for me because as you know, that had some seasonal meeting before only. Or I have this,
Okay.
I met other supervisors also only every 2, 3 weeks. So like this weekly meeting requires you, it's basically to me like a deadline every week, right? So you want to get some new results every week. So it's more stressful. But
Sure.
yes, the overall the experience was really well, I would not say like it's perfect, right? But like it's just very cool to see different people and then how what they really focus on, and then yeah, how they supervise you and how they work together. So it's definitely very different, and I encourage everyone to do the internship in the industry during their PhD,
Yeah,
because they're
sure.
more connected to the industry as well, to know what they need as well. Yeah.
Yeah. And so, do you have the option to kind of continue the project once you're back after your internship, or do you have to wrap everything up before you leave?
Yeah, so at Meta, I was able to continue because we were able to extend it basically part-time. Like so I was
Okay.
20% still with Meta even when I was back in the university, and I was 80% with ETH at that time. So 20% with Meta. So this allows me to continue using the resources and then keep discussing with the people there about the project.
Yeah.
But at Google, it was not I was not that lucky to, so we were not able to get this extension um basically back to the home university. So what I did is like directly extend for 1 more month full time in the US, and then like we try to finish the project there. Yeah.
Okay. Yeah, sure. And how was the interview process to get into all these internships? Like, what did you go through in order to enter Google internship?
Yeah, so again, I was a little bit lucky in the way that so both place in Meta and the Google, I was actually invited. So like
Yeah.
the manager reached out to me and they said,
Hmm.
"Hey, do you want to do an internship?" I said, "Oh, why not?" So then like they start the interview process. And then also like I know that most people need to do this coding interview even for the internship, right? For
Yeah.
me, I was lucky that like, I think neither of it like asked for any like lead code question or also, so I
Ah,
was actually able to just like discuss my research, and also maybe they ask some questions, some machine learning questions, or also some 3D computer vision questions,
yeah.
something like that.
So
Yeah.
how many rounds of interview was that?
For Google was 2 rounds, so 2 rounds of interview with different people, and with Meta, I don't really remember. I think maybe also two or one or two, something like that.
So was that coding interview with Meta?
Also no, so like I
No.
was,
Okay.
but I know like from the year after me, like they start doing the coding interview.
Okay. Okay.
Yeah,
Yeah.
yeah, yeah.
Makes sense. At that time, there were very, very few people working on like 3D stuff and deep learning stuff. So
Not as many now.
as now, yeah, yeah. Yeah, you said like you've obviously attended quite a few conferences by now, like CVPR and NeurIPS. So, what are your tips to kind of navigate these kind of conferences
No.
to make the most out of it?
Yes, so first I think the conference itself, it's what I care the most is actually interact with people, right? So I still remember like the very first time I was doing I went to the conference was like ICCV 2017 in Venice. That was basically presented my work, my master thesis work in a workshop in ICCV, right? And at that time, what I do was that I every day in the evening I was marking, hey, what's the papers I want to check on the second day, right? I was like,
Yeah,
they care a lot about like what kind of papers I can learn. So yeah, that was good. That was good, but also very tiring. But and then I realized that afterwards, during my PhD, I think what's actually matter is that the people you meet, right? So you
yeah,
want to interact with many people there as possible, right? So just try to interact with your peers. Like you never know what happen in the future. You will interact with them again in the future, as I said, right? So one of my projects was coming out from just a chat with some other people in the conference, right? So it's a you never know what will happen, and then like the I think the just social this social kind of aspect of the conference is the most important thing.
Okay. Okay.
More important than the paper, because by the time you go to the conference, the papers there are already outdated, in my opinion. So,
Yeah, the speed at which
because
all
like
this. Yeah.
exactly like there are a lot more like better papers, more sought out paper appears on archive already at that time.
Yeah.
So
So is it true that like people fix jobs in conferences? Like you just meet a professor, just talk to them, and then they say like, okay, you can join my lab. You know.
yeah, exactly. So
Okay.
this happens a lot, right? This happens a lot. So I also know that some of my colleagues, they just basically they already know that, oh, they want to work with this professor, right?
Okay.
Or
Yeah.
a few professors, they went there and then try to talk to them and then see, hey, do you have a opening or something? So I think like we're a good match. So sometimes if the professor really has an opening, then they say, oh, let's have a chat after the conference, right? So you basically you can easily build connection, because like when you directly just send out the email, cold email to the professor, usually they won't reply, right?
Yeah.
But when you meet each other in person, like it's a first-hand feeling for the professor as well. So that's basically make the whole process easier.
Yeah. Sure. Sure. Yeah. Makes
Not
sense.
just postdoc, also for PhD. I think many people also just use it as a way to get the maybe interview for the PhD as well. Yeah.
I see. Yeah. Okay. Yeah, we are moving towards last few questions. So, what is your
Oh,
bet on artificial general intelligence?
what's my bet on that? Oh my
What's your
God. I think also before I was not very sure about. So first, I did not think this very thoroughly, but I think so that's definitely gonna happen. And it's just a matter of time. And then I think now it's really getting closer and closer in many ways, right?
Yeah,
But I think AGI in general like can really help our lives in different perspective, right? So I have, for example, even just GPT, ChatGPT, and GPT-4, I have been using this basic basically every single day. I use for many different tasks of my in my life. So like I use it a lot for helping me with email writing. I use it a lot for like the solving the coding questions as well, right? And also use it a lot to refine my PhD thesis, etc. So I was using this basically on a daily basis. I also like I mean, sometimes my parents need something from me like to post on their social media. I actually generate with ChatGPT for them as well, and then they all love it so much. So this actually already changed a lot of our lives. And also, I mean, now like when I go on a trip, I even ask them, and then usually you get some really nice recommendation, etc. Like so, even just this kind of tool, I already changing people's life
yeah,
significantly.
definitely.
Yeah, but like so in the future, I would say just definitely people's life will be further changed by the AGI.
You've worked with top researchers in the field consistently. So, what is the qualities that cuts across all of these people? Like, what are the qualities of a good researcher across the board?
So at least I for the people I really admire, right? So I think I really admire them in a way that so there are several key traits I would say. So first is like the passion. So
Yeah,
they are passionate about what they are doing, or like what they I think they just love what they do, right? And
yeah,
obviously there, even though like there are so many papers coming out every day there, but they really believe in what they have been working on, and then like they believe in that, and then they have the passion in it. So this will help you to really move to the next level, right? And then the second thing is I think uh I mean, well organization is very important as well. So like for example, one guy I really admire is that like so he really have a so he's a to me is he seems to be crazy to me because like how he so basically I'm talking about Andreas Geiger, right? My second supervisor. So he has so many PhD students, and then also every semester he need to give at least 1 to 2 courses, and then he's also the head of computer science department, and then he's also the fellow of this Alice program in Europe, right? He has a lot of administration tasks. And at the same time, he had 3 kids, and and then like, and then he actually need to take care of the kids, a lot of times. So he actually work from home from time to time a lot, and he managed to do everything so greatly. So about I think like so the efficiency is the key for him, and also like how he's a super organized person, and then yeah, I think
Time
that's
management.
without the time management, I think. Yeah.
Okay. Yeah,
So I
sounds
think
good.
these, at least like these two are the key to
Yeah,
me.
definitely. I agree with you. I've consistently what I've seen across the board is the passion. Kind of
Yeah.
people who are just devoted their life to sort of solving certain problems are really, really passionate about that. That's what
Yeah.
I've understood
Yeah.
over these years. Like,
Yeah.
so what's the one piece of advice you want to leave for the future researchers or the current students in the field?
For well, for researchers, I don't think I'm eligible to do that. But just since I just finished my PhD, right? So I
Yeah.
think so for all the students who is doing a PhD or wanted to do a PhD, I think to me, I think the PhD is one of the best things I have ever done in my life. Not just not about like oh how many papers I published during my PhD. No, it's about so I think PhD is a unique experience for you to really able to make you a better person in different perspective. So like why I'm talking about that? So you basically will earn or learn a lot of abilities that you won't have a chance to learn if you don't do a PhD. So if
Sure.
you are in company, maybe you will be very um good at coding or like good at like time management or like efficiency. But in a PhD, you have to, for example, you are trained to become a independent researcher, right? So you are forced to be able to find a meaningful topic to work on, and then you are forced to basically basically come up with some cool ideas, and then you're forced to like review all the whole field, and then basically and also coding, and then write a paper, and then like if the paper did not get in, you need to know how to do the rebuttal. If it's get in, you need to I don't know, do the presentation in front of like thousands of people, and then also need to clean your code, and you need to make it public, and etc etc. So like all of these are different kind of I think um unique ability that you won't be able to learn from other things. So for me, I think, yeah, well, if you want to do a PhD, go for it, and you'll definitely learn a lot
So
of
let's just wrap up with a rapid fire. So PyTorch or TensorFlow?
PyTorch
PyTorch, always, everyone.
uh,
Sorry, academia or industry?
industry. Well, I will go for industry for now, but maybe academia afterwards. Yeah.
Okay. Google or Meta?
Google,
Google, okay. Face to face or work from home?
face to face.
Face to face. Interesting. Coding or reading paper?
Um, wow, it's hard. I mean, if I have to choose, then maybe coding. Yeah.
Okay, yeah. You want to be hands on then.
Mhm.
Interesting, yeah. Right, that wraps up our chat actually. So thanks so much for taking the time off, Songyou. Yeah, it was really nice catching up with you after
Yeah,
ages. Yeah,
exactly. Thank you so much, Rini, and also for having me here.